Hello, and in this session we'll solve system of linear equations by using the elimination method. And here are the 6 steps in which to accomplish that. To solve a linear system by elimination, the first step is we'll write both equations in standard form, and standard form is ax plus by equals to c. That simply means that both your x and y variables are on one side of your equation and your constant is on the other side. Since this is the elimination method, we're going to transform so that the coefficients of one pair of variable terms are opposite. So we should multiply one or both equations by the appropriate number so that the sum of the coefficients of either x or y terms are 0. The third step is we'll add the two new equations to eliminate a variable. The sum should be an equation with just one variable. The fourth step is we'll solve the equation from step 3 for the remaining variable. Step 5, we'll substitute that newfound result from step 4 into either of the original equations and solve for the other variable. And the sixth step is to check your solution. So let's take a look at an example. And in this first example, we're asked to solve the system of linear equations by elimination. We have 3x plus y is equal to 8, and 5x minus 2y is equal to 6. So upon examining our linear system, we see that for our x variable, we have a coefficient of 3 and 5. Together they have a common multiple of 15. So it's possible to have a positive 15 and a negative 15 combination. If we look at our y variables, we have a coefficient of 1 and negative 2. The least common multiple is 2. So it's possible to have a positive 2y and a negative 2y. So I think what I'll do here, in order to eliminate the y variables, I will multiply my top equation by 2. So I'm going to distribute the 2. So we have 6x plus 2y is equal to 16. Our bottom equation will remain the same. 5x minus 2y is equal to 6. So now if we add them together, we see that the y variable will eliminate itself. 6x plus 5x is 11x is equal to 22. Notice that we have an equation in one variable, so we can now solve for x. So we'll divide both sides by 11. Therefore, x is equal to 2. To get the other variable solution, we'll simply substitute this newfound variable into either of the original equations. So I'll take the first equation, 3x plus y is equal to 8, and we'll substitute x for 2. So we have 6 plus y is equal to 8. I'll subtract 6 from both sides. Therefore, y is equal to 2. So our ordered pair solution is 2, 2. Let's take a look at another example. And in this example, we're asked to solve the linear system once again by elimination. X plus 4y equal to 9. And we have 3x is equal to negative 2y plus 5. If you will remember from our steps, the very first step is to write both equations in standard form. Our first equation is already in standard form, so I'll just move that equation over. That bottom equation, we should add 2y to both sides. So the bottom equation in standard form is 3x plus 2y is equal to 5. So if we look at our x variable, we have a coefficient of 1 and 3, which gives us a multiple of 3. So it's possible to have a positive 3x and a negative 3x. If we take a look at our y variable, we have a coefficient of 4 and 2, which both have a least common multiple of 4. So it's possible to have a positive 4y and a negative 4y. So I think in this instance I will eliminate the y variable. So I'll simply multiply our top equation by negative 3. Therefore we have negative 3x minus 12y is equal to negative 27. And our bottom equation stays the same. And now we'll add both equations and eliminate the x variable. So we have negative 10y is equal to negative 22. We'll divide both sides by negative 10. And we'll reduce, so y is equal to 11/5. To get our x variable, we'll simply substitute y is equal to 11/5 into one of our original equations. So once again, I'll take the first equation, x plus 4y is equal to 9. Y is equal to 11/5. So I'll simply substitute y for 11/5. So we have x plus 4 times 11/5 is equal to 9. I'll simply multiply 4 and 11/5. So x plus 44 over 5 is equal to 9. Next, I'll subtract 44 over 5 from both sides. So x is equal to negative 44 over 5. And I'll also rewrite 9 with a denominator of 5. So I'll express that as 45 over 5. And once we simplify, we see that x is equal to 1/5. So our ordered pair solution is 1/5 and 11/5.